Okay. First one. Okay, I have the equation 2x minus 7 equals 1/3 x minus 2, okay? The reason being is always going to be your given, okay? So that first reason, if you know nothing else, you can at least get points by always stating your given, okay? So the first row of your proof will always be what they give you, and the reason will be given, okay? So you will always write given for number 1, okay? Then you just start solving, okay? So what is the first step that I'm going to do in order to solve this algebra problem? Add 7 to both sides, sure. Okay, when I add 7 to both sides, what am I left with? 2x equals plus 5. Okay, and the reason is I added 7 to both sides. That's how I can say that 2x equals 1/3 x plus 5. Okay, now what? Subtract 1/3 x. When I do that to both sides, what am I left with? 5/3x equals 5. Okay, so step 3 was I subtracted 1/3 x from both sides. Okay, now what? Okay, multiply by 3/5 or divide by 5/3. Okay, if we multiply by 3/5. Okay, so step 4, what are we left with? X equals 3. So 4, we multiplied both sides by 3/5. Okay. So this essentially is a 2-column proof, okay? We wrote out exactly what we did, okay, but little do we know that rather than having to write out all of this stuff, there are properties that we can put in place of this, okay? So if you look at the bottom of that page, we have all of our properties, okay? You do have to know these all, okay? So right now we're going to go through them. We're not going to spend a whole lot of time because I want you to see them in action, okay? A lot of these won't necessarily make sense until you see some numbers involved, okay? So the first one is addition property of equality, okay? If A equals B, then A plus C equals B plus C. So if these two are the same, then if you add something to it, then it's still going to be the same, okay? The next one is subtraction property of equality. Oops. Okay. It's very similar. If A equals B, then A minus C equals B minus C. Multiplication property of equality. If A equals B, then C times A equals C times B. Division property of equality. If A equals B, then A over C equals B over C. Okay, and then the next 3 are the most difficult ones essentially because they're not just add, subtract, multiply, and divide. You actually are going to have to memorize them. Okay, the reflexive property is just that a number is itself, okay, or a segment is itself, or an angle is itself. Okay, so A equals A, or AB equals AB, whatever you may have, but you have to use the reflexive property to say that they are equal to each other. Okay, substitution. Okay, if A and B are real numbers and A equals B, then A can be substituted for B. Okay, I want you to add something to this. We use substitution with operations. So use with operations. What's an operation? What's an operation? Very good. So like adding, subtracting, multiplying, and dividing. Okay, substitution is very similar to transitive. Okay, if you look underneath, substitution, it's underneath this little Doceri little trial logo there. It says if A equals B and B equals C, then A equals C. Okay, here it's similar in that we are saying one thing is equal to another. Okay, however, there are no operations involved. Okay, so when there are no operations involved, okay, we use the transitive property. Okay, so that was our list of properties. If we go back to the warm-up, okay, number 1 was given. 2, what could we put instead of added 7 to both sides? Very good. Addition, property of equality. And instead of writing all those words, we just refer to it as APO. Okay, you just take the first letter of each of the words. Okay, step number 3. What would it be? SPO, subtraction property of equality. Awesome. And then step number 4, MPO or DPO, depending on what you wrote there. If you divided by, was it 5/3? If you divided by 5/3 or you multiplied by 3/5, so you could have different things there. Okay, so MPO and then there's DPO. Okay, so rather than writing what you literally did, we can list those properties. Okay, how do we feel on the first page? Pretty good so far? Okay, hopefully we haven't lost anybody yet. Okay, turn the page. In your groups, I want you to look at those 10 statements. Okay, you have 10 statements there, and I want you to identify which property was used in each statement. Okay, so with your groups, identify which property was used in each statement. Go. All right, here we go. Let's see what you guys found. All right, number 1, if AB equals BC and BC equals CD, then AB equals CD. What do we get for that one? Transitive property. Okay, we only abbreviate on APO, SPO, DPO, and MPO, so make sure you're actually writing transitive, not TP. Okay. Number 2, if 3x equals 120, then x equals 40. How did they get from 3x equals 120 to x equals 40? They divided by 3, so what should number 2 be? DPO. Oops. Okay, number 3. Okay, so a lot of different things on this one. If AB equals CD, then AB plus XY equals CD plus XY. APO, very good. Okay, tricky one, number 5. If measure of angle 1 plus the measure of angle 4 equals 48, and the measure of angle 4 equals the measure of angle 3, then the measure of angle 1 plus the measure of angle 3 equals 48. Substitution. Very good. Why was this one not transitive? Because it has operations. Okay, so substitution here, you have 1 and 4 equals 48, and 4 and 3 are equal to each other, so they substituted in 3 for 4. Okay, so notice how we started with 1 and 4, and we ended with 1 and 3, because 4 and 3 were equal to each other. Okay, so that is substitution. Okay, if 3/4 x equals 20, then 3x equals 80. MPO. If you use DPO on that one, that would have been fine as well. Okay, number 7. If HN equals YT, then HN minus AB equals YT minus AB. SPO. 9, angle H is congruent to angle H. Reflexive. And the last one, if HG is congruent to CD and CD is congruent to LO, then HG is congruent to LO. Transitive. Why is it not substitution? Because it doesn't have any operations. Okay. Transitive is also known as your middleman term. Okay. When the middleman is the same, they can drop off. So HG is congruent to CD, CD is congruent to LO, CD is are the same, so that's our middleman. And if we just drop them off, we have HG is congruent to LO. Okay, so that's another way to identify the middleman. Okay, if they're congruent, the same, and as long as there are no operations, they can drop off and be transitive. Okay. Questions on 1 through 10? No questions so far. Awesome. Okay, in your groups again, you are looking at A through G. Okay, you have a little word bank there. You are going to use every one once. Okay, so work through that with your group. Go. Let's look at these real quick. You guys call them out as I go. If 3x minus 7 equals 14, then 3x equals 21 by APO. Very good. Letter B. If 5x plus 5 equals 10, then by ESPO. C. If 1/2 x equals 3, then x equals 6 by MPO. D. If 5x equals 20, then by E. If 3 parentheses x plus 2 equals 1, then by. Very good. If the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3, and the measure of angle 2 equals 30, then
the measure of angle 1 plus 30 equals measure of angle 3.
Very good. I'm going to run out of room. By what?
Substitution.
Very good. Does everybody understand that one?
Yes, ma'am.
Awesome. G, if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then? Very good. By? Awesome. Okay, do we notice now the difference between substitution and transitive? Okay, so anytime operations are involved, we are going to use substitution. Okay, transitive, okay, our middleman here lines up, it drops off, and then you have 1 is congruent to 3. Okay, 1 is congruent to 3. Okay, what is the difference between substitution and transitive? Tell me. Very good. Substitution uses operations. Okay, I am going to write a little bit more than that, okay, for purpose of the test. So, write this with me. Transitive is drawing conclusions. And two parts are not necessarily equal to each other right away. Substitution is used with operations. Okay, we're going to see this more as we continue to work with more examples, okay? So transitive is drawing conclusions, and two parts aren't necessarily equal to each other right away. Okay, we need that third piece. Okay, substitution is used with operations. Questions? Okay, so far so good. Okay, I'm going to do this first one with you guys, and then you are going to do the remaining three. Let's go through this. Statement and reasons. As I stated, the first one is always going to be the given. Always, always, always. You can always at least get some partial credit if you just give me the given. Okay? If you know nothing else, just give me what it gives you so you can at least get 2 points or however many it is. Okay? Step number 2. How did we get there? Multiplying both sides by 3. So what would I put in the side there? MPO. 3, how'd we get there? Distributive. Okay. 5x minus 21 equals negative 6. How'd we get there? SPO. Step 5, 5x equals 15. How'd we get there? APO. And last but not least, x equals 3. Depot. Very good. Okay, so on that one, I gave you the left side and you were filling in the right side. Okay, on the remaining 3, okay, both sides are blank. So you're going to have to figure out what goes in both of those blanks. Okay, hint there's the correct number of blanks for every step. I want you to add a line at the beginning because I want you to get used to naming this reason. Okay, so put a line next to each of your equations that are already there. So get used to writing what goes in that blank that I just drew. Given. Given, given, given. Okay, work with your group on those 3. Go. All right, here we go. First one. First reason should be what? Given. Okay, then I'm going to go ahead and solve. And then you guys are going to tell me the steps. Okay, what is my second reason? Distributive. What is my third reason? And my fourth reason? Depot. Oh, geez, sorry. Thank you. Okay, questions on the first one. Okay, number 8. Okay, I have... First one. Second one. Third one. Did we mess up? No. Okay. APO's first. Because I added 3x to both sides. So that's APO. Depends on what order you did it. Then it would have been SPO. So just like PEMDAS, how addition and subtraction go together and multiplication and division go together. Okay, if you flip them in the order of your proof, it's okay because they are interchangeable. Okay, and then my last step. Depot. Questions on number 8. Okay, moving right along then. Last one. Given, I have 6x plus 24 equals. Okay, second reason. Distributive. Third reason. Fourth reason. Fifth reason. Awesome. Questions on that one? Okay, so that is all of the algebra. Okay, now we are going into the geometry part of it. Okay, so again, it's going to take practice. After we get through this first one, you're going to be like, what did I sign up for? Okay, but then after we hopefully work through the rest of the day and then into next class, because next class is all proofs as well, hopefully we start gaining confidence day after day. That's the goal. Okay, but if you're confused at the beginning, it's okay. We're going to have to persevere through it, okay? So, first one. If you know that two angles are right angles, what can you say about them to each other? Prove it. They're congruent. Very good. Angle 1 and angle 2 are right angles. Prove that angle 1 is congruent to angle 2. What is the first thing that goes under my statement and my reason? Given. The given. So what am I writing? Angle 1 and angle 2 are right angles. You literally write exactly what it says. And boom, 2 points. So if you know nothing and you have no idea what to do next, at least write your given, because that's automatic 2 points. Okay, it kills me when people leave it blank and just don't do the proof when they're fully capable of at least copying down the given. Okay, so we need to prove that 1 and 2 are right angles. What do we know based off the diagram? What do we know so far? They're 90-degree angles. How do we know that 1 and 2 are 90-degree angles? Not just because of the symbol, but more importantly, because they're right angles. So we know that the measure of angle 1 is equal to 90 degrees. We also know that the measure of angle 2 is equal to 90 degrees. Okay, the reason being is what you guys just told me. Definition of right angles. So that's what you would write there. Definition of right angles. Okay, now using the properties that we just learned, what can I do next after I have 1 is equal to 90 and 90 degrees is equal to measure 2? Okay, I could have written this in the other order, but I wrote it this way on purpose so that we could hopefully identify the property that we need to use. Raise your hand for substitution. Raise your hand for transitive. Very good. What can I say based off this in using my transitive property?
Measure of angle 1 equals 90.
Okay, so we can drop my 90 degrees, and so I'm left with what? Measure of angle 1 is equal to the measure of angle 2. So that is the transitive property. Okay, what happens when the measure of 2 angles are equal to each other? They're congruent. So we've arrived at our proof. Angle 1 is congruent to angle 2. What do you think our reason for that is? So moving from 3 to 4, what would be the reason to say that they are congruent? What would be the reason that they're congruent? What did you say, Miranda?
I didn't.
But, like, you told me that they were congruent. Why?
I'm not sure.
If the measure of angle 1 equals the measure of angle 2, based off that, how did we say that they're congruent? Because the measures are equal to each other. That's all, okay? Congruent means same, so they're equal to each other. So all you would say for number 4 is definition of congruent angles. And you can shorthand things so that you don't have to write so much. Definition of congruent angles. So symbol, 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 but make sure I know what your symbols mean. Okay, don't start making your own. So definition of congruent angles. Okay, that was proof number 1. How do we feel? Okay, so far? All right. Of course, we're going to spice it up. But any questions on the first one? Okay, moving on then. Okay. AB is perpendicular to BC. DC is perpendicular to BC. And prove that angle B is congruent to angle C. So notice this one, we only have on here it says 3 steps, but I'm actually going to make it 4 steps. Okay, so you can add a step 4. Okay, what's going in line 1? You're given. Okay, so write it directly as you see it. AB perpendicular to BC. DC is perpendicular to BC. And Y given. Okay, so after you write your given and you're looking at your picture, you're thinking to yourself, what do I know based off my given statement? Okay, if AB is perpendicular to BC and DC is perpendicular to BC, what do I know about that? What do I know based off the fact that those things are perpendicular? They form right angles. What angles are right angles? Complementary are right angles. But I'm saying in this diagram, what angles would be right angles? Very good. So write that. Measure of angle, and I'm just going to use B because there's only one angle coming from B. So the measure of angle B equals what? 90 degrees. And the measure of angle C is equal to what?
90 degrees.
Very good. Why is that? Definition of, not necessarily right angles, perpendicular. Okay, so perpendicular lines or segments or whatever, okay, are always going to intersect to form right angles. Okay, so that would be our reason. Okay, again, I wrote it this way on purpose so that hopefully we can identify the next step. Okay, how could we move forward?
Transitive property.
The transitive property. And so what am I left with after applying the transitive property? Measure of angle B equals the measure of angle C because of the transitive property. Sweet. Okay, now I have two angle measures equal to each other. So what can I say next? Angle B is congruent to angle C. And what is my reasoning?
Definition of congruent angle.
Very good. Questions on the second proof? Okay, I personally think the second step is always the hardest because you have to figure out where you're going. Okay, once you can identify that second step, the rest tends to flow. But it's going from the first to the second. That's the hardest part. Questions? All right, of course, yes.
So, like, if we didn't see that picture right there, would we have been able to get number 2? Or, like, would that always be a picture?
What do you mean by?
Like, we have been able to figure out steps, like, 2 and
I mean, you could have drawn that picture yourself.
But how would we know that, like, point C and B were on the same line?
Because you would have to draw that AB is perpendicular to BC. And then DC is perpendicular to BC. So you just have to know that those things are perpendicular. And they're segments, so they shouldn't be lines. You just have to draw it. But there will be pictures 99% of the time. These right angles might not be labeled though. You would have to know that those are right angles because it's perpendicular. I can almost guarantee that they will not be labeled. Okay, next one. Alright, of course, we're spicing it up. If you know that two angles are supplementary to the same angle, what can you say about the original two angles to each other? Prove it. Okay, our first one says, given angle 1 and 2 are supplements, angle 3 and angle 2 are supplements, angle 1 is congruent to angle 3. What does it mean for it to be a supplement?
They're supplementary.
They're supplementary angles, which means they are equal to 180. So are we starting to see why we have those vocab quizzes? Okay, and how important vocabulary is going to be, especially with proofs. You've got to be able to know what all these terms mean. If you didn't know what supplement meant, you would have no idea how to do this proof. Okay, so really keep up with that vocab. Even though we just took a vocab quiz, don't just like throw away everything. Okay, make sure you're retaining those vocab words. Okay, what's going in at line 1? Given. So you need to write both of them, so you're going to have to write kind of small. Okay, so based off of our given, 1 and 2 are supplements and 3 and 2 are supplements, what do we know? If I told you 1 and 2 are supplements, what would you tell me back?
1 and 3 or something.
1 and 3 are congruent.
Pause. If I told you that 1 and 2, angle 1 and angle 2 are supplementary, what would you tell me?
They add up to plus 82.
They add up to 180 degrees. So start writing what you know. Okay, so we know that measure of angle 1 plus the measure of angle 2 equals what? 180. We also know that angle 3 and angle 2 are supplementary. So what can we say about those?
Measure of angle 2 plus measure of angle 2.
Equals what? 180. So the measure of angle 2 plus the measure of angle 3 equals 180. Okay, what would be the reason for that?
No.
Definition of supplementary angles. Okay, so we're trying to prove that 1 and 3 are congruent. Okay, we're trying to prove that 1 and 3 are congruent. So before we can prove 1 and 3 are congruent, what do you think my step before that's going to look like? So what has been the format in the other 2 proofs that we've done? The step before their measures were equal, right? And then we got to it that they were congruent. Okay, so we're going through that same idea here. Okay, so after I have 2 things equal to each other, okay, what could I do? Substitution, what way? How?
Angle 2 is angle 3.
Okay, so what am I substituting 2 and 3 and 4? So 1 and 2 equals 180, and 2 and 3 equal 180. What can I put 2 and 3 in the place of?
180.
180. Okay, do we see that?
Yeah.
So if 1 and 2 equals 180, and 2 and 3 equals 180, I can say the measure of 1 and 2 equals the measure of 2 and 3. Okay, so write that. The measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And why was that? Substitution. Okay, that step can be tricky, so ask questions if you have it. Yes.
Why isn't it like the transitive? Because you're not.
Because there's operations.
Okay.
Yes.
So for substitution, will you always use substitution if you have 2 equations that equal the same number?
Essentially, yes.
And then like the substitution part is always taking out the number portion. Like that they both have the same just.
Well, this could have been all variables if you wanted it to be. If A plus B equals C and D plus E equals C, A plus B could equal D plus E. So it doesn't always have to have a number that drops off. It can be just the common part. Okay. Now that we have measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3, I know that eventually I want to get just 1 and 3. Okay, what can I do? Can we drop transitive here?
No.
No, why? There's operations. You can't do transitive across operations. Okay, so better yet, how can I get rid of measure of angle 2? Subtraction. Very good. So if I subtract the measure of angle 2 from both sides, I'm left with the measure of angle 1 is equal to the measure of angle 3. What was my reason? SPO. Very good. Okay, now I have the measure of angle 1 is equal to the measure of angle 3. So what can I say? Very good. Angle 1 is congruent to angle 3. Why? Very good. Definition of congruent angles. Are we slowly catching on?
Yeah.
Okay, each one, granted, is getting harder. Okay, but like I said, I think that second or third step typically is the hardest. Okay, once you get there, it flows usually. I would say the third step on this one was the hardest to see. Yes?
Does it matter which way the squiggly line on the congruent thing
No.
is?
Okay. Questions? Y'all are doing great. Y'all are catching on way faster than we did last year, so that's always good. Okay, moving on then. Ooh, fun one. WX equals XY. Prove WY equals 2XY. Okay, what do we know so far? The given. So WX equals XY. Oh, sorry. Thanks. Okay, so we know that these two pieces are congruent, and we want to prove that WY is equal to 2XY. Ideas. Anybody have ideas? What do we know about this segment WY? WY, what do we know about WY? It's what? Okay, is that true? WX plus XY equals WY?
Yes.
All right, let's write it. What would be the reason for that?
Segment addition postulate.
Very good. So these are from last class. Segment addition postulate. Do we recall what that was last class? Okay, segment addition postulate. Okay, so again, how big of a role does vocab play? Huge. Okay, so we have WX equals XY, that's our given. We have WX plus XY equals WY, that's segment addition postulate. Is there anything we can do already? So just with those first two statements, is there anything we can do and build off of? We have WX equals XY. We also have WX plus XY equals WY, and our goal is to get 2XY. Yes.
Substitute XY for WX.
Very good. Substitute XY for WX. So now we have WX plus WX equals WY. Does everybody see that step? Okay. Here we have WX equals XY. So we substituted in for WX here.
Oh, wouldn't you do the XY though? Because we're solving for 2XY's.
Did I mess up somewhere?
Like instead of doing WX, wouldn't it be XY, XY?
Yes. Okay, so good catch. Substitute the other segment. Whee. XY plus XY equals WY. Good catch. Okay, and why is that? What's our reasoning? Substitution. Okay, now that we have it right, do we still see where we substituted? Substitution. Yeah. Okay, now what can we say for step 4?
Determine.
Add your xy's together, so you have 2xy equals wy, and what would be your reason? APO. Okay, it's kind of a truth to be told. If you have an angle that's broken up, chances are you're going to have to use the angle addition postulate somewhere. If you have a segment with no values to it, chances are you're going to have to use your postulates that are associated with segments. Okay? Yes.
Is this be on the test?
This? Proofs? Yes. Proofs will be on your test. Okay. I want to look at your homework. Look at your homework. Remind me to pass back your skills checks before the bell rings. Okay. Given WH equals FB, prove WF equals HB. So on some of these, they're filled out for, well, pieces of them are filled out for you. Okay? And then you have to do the rest. So we're going to do this last one together, and then you're going to struggle through and persevere through the rest of them. Okay? And by struggle, I just meant that they're not easy. Okay? Number 1, what would be my reason? Given. Okay, so I have WH is equal to FB, and my reason is given. And I want to prove that WF is equal to HB. Okay, I want to prove that WF is equal to HB. What else do I know about this graph? Or this picture? Very good. WH plus HF is equal to HF plus FB. Why is that? Why is it segment addition postulate?
Because you're adding seg.
What did you add to both of them? HF. So are we adding segments together necessarily yet? No. So we just used APO. Because all we did was add HF. Okay? I'm going to challenge you guys. Okay? I think, well, I know, there should be another step that's thrown in here before you say that. Okay? So how can you add HF if you've not declared what HF equals? Okay, so in this equation, HF equals what? So if I'm looking at this segment,
WB.
hold on. If I'm looking at this segment, and I'm looking at this segment, HF equals what in comparison? So HF in this segment equals what in this segment? It's the same. And what property is that called? If I say HF equals HF, what is it? Reflexive. Okay, so that's the tricky one that people forget often. Okay, if you're going to use it, you have to at least give it a value, okay? So right now we need to say that HF is equal to HF in both segments. Okay, so we're going to throw in HF is equal to HF by reflexive. Sorry, I got a little messy. Okay, so far we're doing good. Okay, we have our HF equals to HF. We also know that now WH plus HF is equal to HF plus FB. Okay, number 3 says HF plus FB equals HB. How do we know that? So if I know that, or if it says HF, this part plus this part equals this whole part. Very good. Segment addition postulate. Okay? Following in that same kind of order, what else do we know? So we've established what HB is made up of. What else do we need to establish? Very good. WH plus HF equals WF. Okay, why is that? Same thing. I will say, if it gives you any peace of mind, on a test, you'll never have a proof that you haven't seen before. So if you study and do homework and go through your notes, then you'll always be fine. It's never going to be something thrown to you from left field. Okay? You're always going to have seen them at some point. Okay? It might have LTHS instead of WHFB, but it's going to always be the same sort of idea. Okay, so now I have HF plus FB equals HB, and WH plus HF equals WF. Okay, so I have HB and WF. So what can I say? WF equals HF plus FP. Okay, if I do that, WH plus HF equals FB. Okay, how am I going to get that WF equals HB?
I mean, WH plus HF equals HB.
HB. WH plus HF equals HB. Okay, so how am I going to get that just WF equals HB? So do you notice how, like, as you write things off to the side, you'll be able to realize if it's going to help you get to your solution or not? Okay, let's look at my statements that I have so far. WH equals FB, HF is equal to HF, WH plus HF equals HF plus FB. Do I see WH plus HF anywhere? And number 4, what do I know WH plus HF equals?
HF plus FB.
Okay, but it's more importantly equal to WF, right? So what could I put in place here? WF. Where else do I have HF plus FB? Third line, and what did it equal? HB. So now I have WF equal to HB. Why? Why would it? Substitution. So because we put that reflexive step up here, it threw off our numbering, so you don't actually need step 5 because we put 5 technically up here. Okay? So WF equals HB because of substitution. So I kind of said that fast. Does everybody see where the substitution came from? No, I got some no's and yes. Okay, here we go. So we're looking at our statements. We have WH plus HF, and we've defined that as WF. So we can substitute WF up here, right there. Okay? We've defined HF plus FB as HB. So we can substitute HB now in for this. Okay? So now we have WF equals HB because of substitution. Okay, that's why I put that step up here instead of down here, because it wouldn't make sense if I did it the other way. However, if you did it, it's not wrong. Okay? But I just think it's easier to follow if you put it in that order. Okay, so what do you think the most common mistake or most left off piece is on this proof? The reflexive, okay? And granted, if you forgot it, it's only like 2 points, let's say, but that's also an easy 2 points not to forget. Yes.
Can you explain why we had to do the reflexive again?
Okay, so we just basically have to prove every part. Okay, so if we didn't prove that HF was the same on each, it wouldn't make sense to put it here. Because if we didn't say that they were equal, this could have been plus 8 and this could have been plus 4. So like we needed to establish that we were adding the same thing to both. And the only way to do that is using the reflexive. I know, it sounds silly. And it's often forgotten. That's the problem with the reflexive. But it is important. So, that was a lot to take in. You have 1, 2, 3, 4 more to do. And just give them your best shot, okay? The answer key is online so you can